Hello, welcome back to our channel. And here is another example of a feedback system used in electronic circuits and systems. So what you see on your screen, you have this input current source labeled as IS. Then you have a forward gain block. We call it as a forward gain block because it is from input to the output without any feedback. Okay, so you call it as a gain block, and gain is equal to A. And you have at the input current, and at the output you have the current as well. So this current I out eventually flows through the load resistance RL. Therefore, we say I out is equal to IL, or IL is equal to I out. And the transfer function of this forward gain block is the output current divided by the input current. Okay, where output current is I out and the input current is I in. Now, input current is not IS, rather it is I in. I will explain that in a moment. Now, what you do, you let the current IL flow through the load, and then this current becomes an input to this another gain block, which is called as a reverse gain block because it is from output to the input. So this is a forward gain block. This is a reverse gain block. For the reverse gain block, your input is the I out, which is equal to IL, and the output of this gain block is the current again. That is called as feedback current IF, which is the product of beta times I out. You just take I out and multiply it with the beta. That's why you get IF here. So this current IF is getting mixed with the input current IS at these two nodes, generating the final current I in. So therefore, we can say the forward gain has the transfer function of output current divided by the input current, where the input current is now I in. Okay, so let me write few expressions here for your understanding. So what I am going to do is that I will write I in is equal to IS plus minus IF. I said that this IF is getting mixed with the IS and therefore generating I in. Now mixing means whether the IF gets added to the IS or IF gets subtracted from the IS depends on the kind of feedback, whether positive or the negative. If you have a feedback, negative feedback, for example, then I in is equal to the difference between these two currents, and any difference error that is becoming now the input to this gain. And on the other hand, I in is equal to IS plus IF if the feedback is positive. Now you are sensing an output current here and you are generating a current again. So this block has a transfer function of current amplifier. You see the output current divided by the input current. This gain block has a transfer function of current amplifier again. So output current divided by input current. Okay. And the kind of feedback, we call it as a current shunt feedback. Why? Because you are sensing an output current. At the output side, you are sensing a current. And at the input side, you are mixing the IF with the IS. So in parallel, there is a parallel connection. Therefore, we call it as a shunt connection. And therefore, this type of feedback is called as current shunt feedback. Okay, this is popularly utilized in the design of current amplifiers. So remember that. So hope you understood this basic concept, and if you like this video, like it, share it with others, subscribe to our channel, and stay tuned for more informative contents like this. Till then, wish you happy learning.